Okay, we are about to finish up this worksheet. This won't take very long to finish up. I recommend that maybe you pause this and fill these answers out for number one, and then just check them off about the answers I'm about to give you. Because we talked about this in the last video about shifts, and so you can try it and see if you get it right. The answer to A is capital B, because this is a shift to the right 7 units. For part B, the answer is capital D, because this is a shift down 7, a vertical shift. C, this is a vertical stretch by a factor of 7. This is E. D is capital A, because this is a horizontal shift left 7. And the 1/3 in there with the X is a horizontal stretch, and this one is C. So that's the answers for number one. Okay, for number two, we are supposed to determine the largest intervals over which the function is increasing, decreasing, or constant. Find the intervals or the X values where the function is going up, increasing, going down, decreasing, or staying the same. Notice that the answers that we will write down are only X values. We're only recording X values. So we're talking about whether it's going up or going down. So when I look at this first problem, this is my parabola. Before the vertex, it is going down. It is decreasing up into this point. What X values are those? It's decreasing from negative infinity to 3, negative infinity to 3, and then once it hits 3, it begins to increase from 3 to infinity. So 3 to infinity. I am of the opinion that you may always, it is always appropriate to use parentheses for intervals of increase and decrease. You don't ever have to use a bracket. I have seen a textbook or two that use a bracket in some specific cases, but I think it's, you can just about always get away, and I think it's appropriate to use parentheses. Brackets, however, no, not all the time, because look at this 3. Does the 3 belong to the increase part or the decrease part? It doesn't belong to either one, and so that's why we put a parenthesis right there. There are no parts where this function is staying the same, so there are no intervals where it's constant. There's none. All right, where is this function increasing? Okay, it's going down, and if it helps you, you can just kind of draw an arrow, and that just help. Then it's very visual. You can see what it's doing. Okay, it's going down, it's staying the same, it's going up. When it's going up, it's increasing. So that's from X is 4 to infinity. 4 to infinity. It is decreasing, from the moment it's born at negative infinity all the way to X is -1, negative infinity to -1, and then it's constant from X is -1 to 4. -1 to 4. Notice that I am not recording any Y values at all. Now these Y values, this 3 Y value told me that it stayed the same. That helped me know that it was horizontal. But I don't write down the 3. I just only write down the X values when they ask for intervals. Increase. Where's this guy increasing? Okay, from the moment it's born, from X is negative infinity all the way up to this X value, 1. From negative infinity to 1. It is decreasing from X is 4 to infinity. And where's it constant? Right here in the middle, from X is 1 to X is 4. All right. How about this guy? Well, if I look at this, it is always in a state of decline. It is always decreasing. So there are no intervals of increase. There are no constant intervals, and it is decreasing from the beginning to the end, from X is negative infinity to positive infinity. This guy right here, decrease from negative, what are these? I didn't write down these points, so let me write down these points. This is -3, no, what is this? Let me make sure I do this right. -2, 2, -2, 2. This is -2, -2. This is 3, -2, and this is 3, 1. Is that right? No, let me make sure I write that. 3, -2. Oh, this is 3, 1.5. 3, -2. Okay, good. So let's write this down. This one is 3, 1. 3, 1. All right, so let's see. It's decreasing from negative infinity to x is -2. Negative infinity to -2. And then it's constant from x is -2 to 3, -2 to 3. And then it's decreasing again. It's still going down from x is 3. So I can put a union there, 3 to infinity. You can also just put a comma if you want. Where is it increasing? It is never increasing, so there's no intervals of increase. Okay, right here, this one, decreasing, constant, increasing. So where is it increasing? From x is 3 to infinity. Where is it decreasing? From negative infinity to -3. Where is it constant? From -3 to 3. All right. Let me just make sure my answers, I agree with those real quick before we go ahead. -3 to infinity, this, yes, yes. Yes, yes, yep. 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 Yep, yep, yep. Decrease, constant, none, okay. 3, yep, yep, okay, good. The last one. This is, we need to interpret these two graphs. We need to call out 3 things, 3 answers. 1, where does the first graph, the red graph, y1 equal to y2? In other words, where are they intersecting? That's the question. Part A, we're going to answer. Where does y1 equal to y2? So let's go through each of these and answer this. Okay, just look at this. Sometimes I write my y's like that. Sometimes I write them like that. Sometimes I write my 2's like that. Sometimes I write my 2's like that. Nothing special is going on. I just sometimes write them different, so it doesn't mean anything special. Where are these equal to each other at the points, at the x values where they're intersecting? They are equal here, at this point, and here. So the answer to part A is when x is -1 and when x is 6. All right, let's go on to this graph. Where are these graphs intersecting? At this point and this point. So right here, the answer to A is at x is 0 and x is 8. All right, where are these graphs intersecting? Only at one point, right here. And so the answer here is at x is 4, just like that. Where are these graphs intersecting? Well, they are not, so there's no solution for part A. No solution. Okay, for part B, they want us to answer, where is y1 greater than y2? Where is, oh no, less than, let me get this right. Where is y1 less than y2? All right, so for what x values is y1, the red graph below less than y2? Where is the red graph below y2? Well, here, from here to here, it's below the blue line, this middle part. Well, what x values are that? Okay, it's below from x is -1 to x is 6. Let's go ahead and answer this part C. Where is the red graph above, greater than y2? Where is y1 greater than y2? Right here, on this, before we get to -1, the red part's higher than the blue part, and then after we get to 6, the red part's higher than the blue part. How do we write that down? Well, we say from x is -infinity to x is -1, and then from 6 to infinity. For those x values, this will be true. All right, let's answer the middle one, B. Where is the red graph lower than the blue graph? Where is y1 less than y2? Well, over here and over here. Okay, so this time, the red graph's below the blue graph from -infinity to 0, and then from 8 to infinity, like that. All right? Where is the red graph higher, above? All right. It is above the blue line from this x value, 0 and 8. So in the middle, from 0 to 8. All right. B. Where is the red graph? Where is y1 less than y2? Where's the red graph below the blue line? Never, excuse me, my dog's tearing up something I love. You cannot have that. Where is, I'm sorry. The red graph below the blue line. It is never below it, so no solution. Okay, part C. Where is the red graph above? Where is the red graph above the blue graph? Okay, it is above from here to 4. What happens at 4? It equals it. It is not above, so we cannot include 4. What happens just to the right of 4? It jumps above it again. So this is how we're going to record this answer. The red graph is above the blue graph from x is -infinity until x is 4. Do not include 4, and then from 4 to infinity. Okay. Part B, where is the red graph lower than the blue graph? Where is the red below the blue? All the time, all day long, for every x value. So part B is from -infinity to +infinity. That's how we'll answer that. Part C, where is the red graph above the blue graph? Never. It never happens. So that's no solution. Okay, and that's the end of this. So you're all done.